Job at hand is the brake drums. Got a little bit of a ridge. There was kind of a nasty spot on the other one. There's a pair of them. And it's automotive, but it's heavy automotive. I imagine these are special drums that they couldn't readily get. I honestly don't know. Yeah, I don't know. But at least they're asking us to turn them either way. So that's what we're doing. And the nice thing is if you have the hubs that they fit, because then you can chuck up on the hub and line up. Next one that doesn't work too bad is you make some kind of a plate if you can. It has a little pilot that this goes on and you bolt these onto. But the size is good enough on it though, so that I was able to put the four-jaw inside here. I stoned this surface before putting it up to the lathe, and then also stoned the face of the chuck, and you'll see over here on the other one how it's mounted up. And what we have is there's T-slots in a lot of your four jaws, and this has those. So we have these 4 sets of clamps here. The clamps, I just barely snugged them a little bit when I first put it in so that I could slide it and adjust the 4 jaws. I did a rough dial in on this part of the bore that was left here. That got me within 10 thousandths, which also told me that this surface is at least a few thousandths off from where it should be, because right when I went from that surface to the inside bore, I was only off 2 thousandths of an inch after I was within 10 there. So I moved it the other 2, then tightened down my clamps, and I'm off by 1 as maximum run out at this point. And that's plenty good enough for brake. I'm not gonna fuss with it again since it's all bolted down. You can see we're on 0 there, our 4-point check. We're on 0 there. 0. Maybe it was less. It's pretty close anyway. Yeah, that one I'm under a half. So it's good enough. It will work. Now I gotta set up a boring bar, and it's gonna want a ring. It's a big bell. Being cast iron, being bolted down solid, it's a little better than if it was more loose, but we're still going to need some stuff here. The common thing is if you're in a shop that does brake drum stuff all the time, they'll have regular stretchy rubber bands, sometimes bungee straps around them with the rubber band or springs. And what we usually have is rags and duct tape. Not as good, but it generally works. You can see, I don't know what's going on with their brakes, but this was the part here I was talking about. Although looking at that, what that might very well be, looking at it, I think it's torch residue. I don't think it's anything to do with the brake itself. I think they had to torch something apart to make this thing come apart. And that was part of what he was talking about. He was having trouble when he worked on them with the big ridge right here. So I will start setting up a boring bar and get my stuff on there, and probably pretty boring. No real reason to film until I get ready for the next step. So we'll let you go back to the office, cameraman. Okay, so now we're getting back here to start our cut. I found a nice piece of some felt matting from underneath a rug. So that'll work good. Lots of duct tape. I'm gonna come in here, I'm gonna touch off near the inside. As you can see where this is the original diameter, it's not worn a whole lot there, but it's worn a whole lot out here. So that'll be the point that I can pick up the highest part of it, because it's just a little step there, big step here, and then I'll come back to the start and actually take a cut, which through a lot of it won't be a cut. I'm set at about 10 thousandths feed rate, and we're at 45 RPM, and we'll see how that works for starters. She's kind of out around, which is what they were saying. Okay, there's a 0. I come back, see that we don't touch anything. Back here to our 0. Let's cut a little bit there too. So now I will take, I'm going to just take a light cut. Let's see how we go for starters. Either on the edge or in the middle is where they'll ring the most usually. So I'm going to disengage it, hand feed it for a ways, because there's, oh, there it's starting to cut a little bit. Yeah, they said it was out around, it is. Cutting so nice, I don't think I'm going to bother trying faster speed or anything. It's just cutting nice. We only got 2 of them to do. It'll take a little bit, but all in all, not that much more to be playing with it.
How much do you have to take off?
Till it's one smooth cut. Don't matter. There's a maximum for a highway vehicle for how much you can take out. I don't have the spec on this particular one, and this is an off-road truck anyway, so. But I have done that on my own vehicles too, where you've got a shoe, they give you a maximum on it because of the maximum amount they figure it's still safe for structure and heat for the size of the vehicle that it's in, for the purpose it's intended for. But you also get into a position where if you go beyond that, which I have done before, your pistons can pop out of your wheel cylinders. Your seals go out too far, it loses its sealing surface and it goes whoop if you get a little too carried away with taking material. Now, what you shouldn't do, but if you were in that situation with an old vehicle you couldn't get parts for, that you were still driving back and forth to work, you might decide to make longer pins for it to make up for the fact that the drum is turned further than what it should have been, which I'm sure never really happened. The worst I did, which I'm sure I'm over the statute of limitations, was when I drove my 63 Willys back and forth to work for 2 weeks with the clutch not able to disengage and no brakes, which is rather tough. There was only a little ice on the ground, but I got really good. You downshift. It was a T90 transmission, old Willys. You synchronize, get it back into first gear, turn the key off. It had a good starter. That's when I finally quit driving that old wagon, was when the starter went out. But I did, in between, I had fixed the brakes and the clutch and was driving it, but the starter was the thing that finally gave up on it when I quit driving it. And oh, if I had it now, I sold it for 200 bucks. 63 Willys wagon. It had about a 10-year-old paint job that was looking like a 5-year-old job. It was nice urethane. The paint alone for that job today cost you $2,000. But at that time, I probably had 90 in it. Because usually I could do them. I used to paint cars for a little while, and I would paint a car with urethane paint for under 100 bucks in supplies. Now I want to watch close when I get to the end too, because I haven't set an exact stop. I just made sure that my bar would go far enough, and I don't want to start taking out more of the casting than I need to. So when I get to the end, I want to make sure I stop it correctly, and then set that as my 0 on the readout. The next cut will be more fun. But this one does kind of tell why they came in here. They said they'd let off the brakes and it would turn around a little bit and lock up again, which kind of looks like that's what it should have been doing. Big old out around spot. Sounds good, it looks good, but sometimes I still put my hand on the bar because you can feel more if the bar is moving from a cut that's not going as well as you think sometimes. You feel a bar move. Just, huh? Yeah. It's the slow cycle vibration, the dipping down is what you're feeling for. Straight vibration is not that big of a deal, but you'll feel a slower secondary that tells you that the bar is dipping. I didn't expect it on the cast iron at all, but I just sometimes do that anyway, just to let people know why I was touching the bar. Something to notice here too, person could sit here and double check themselves and say, oh my Lord, did I get it true? Did I dial it in straight? It's running out so much. But the other thing is, our first cut here took off metal all the way around on that unworn rim. Probably take 2 more cuts after this to finish it up. If we had a plate that it was bolted on, I might try and take a deeper cut, but between the little clamps and the chuck jaws, I just don't want it moving at all. It's pretty secure, but you don't want to push your limits. And setting it up to do it the other way just takes so much more, it wouldn't pay off as far as save time. If we were doing a dozen of them though, we definitely would set up a flange, even if they didn't care what it took just for us. We'd get bored doing these slower when we know we could do it quicker if we set up a good flange. That's getting back into closer to a full cut again. Only thing I can really think of is that they got the brakes real hot and then just came in, stabbed the brakes, and left them axes set afterwards. Let it cool down with an excessive load in one area. Which means also that they may warp again even after we true them. They may warp back to the original stresses where they wanted to be once they've been heated again without the load on them. But it may not do. So I'm taking 20 thousandths now. See what that looks like. I'd say reasonable all the way around. It's not nothing, and it's not too much. I wonder if the other one's going to be as out around. Sometimes you just get one that's like this, you know, it'll give you enough trouble. Then you know which axle it is, but yeah, you should still know when you jack up the vehicle and work with it. If it looks like you got, on a lot of stuff, if it looks like you got a pretty even wear across it, which you can't always tell, but if it's still working good and an even wear across it, I'll just come in with a grinder on my own stuff and just grind that outer ledge off, not bother turning it. What's that?
Does the ledge cause a problem?
Oh yeah, yeah, because when you adjust your brakes, then you can't get the drum off.
Oh.
And it's long ways to adjust your brakes in and get them to slide over this ridge instead of sliding over a straight piece that they're close to. No, the ridge, as far as maintenance, the ridge is the biggest problem. As far as using it, the ridge is not a real problem. But the ridge can be a little bit of a problem too, because you put on a new shoe and they're not always the same width. So you've got a shoe that's worn down into a groove and your new shoe is slightly wider. If your new shoe is slightly narrower, it doesn't cause any problems. So that's something to look at too if you're doing that instead of turning them, is how does your shoe fit? And if you need to, you can take care of the shoe fit a little bit too by taking off part of the shoe on one side. But don't do any of this on a highway vehicle. That's almost going to be a cleanup there, just that one spot. Or I guess it's two spots, but in the same area. Yeah, 40 years ago when the truck shops were doing these, if it was a somewhat standard drum, they'd do this for 25 bucks. I don't know anybody that's doing it today because the common drums are so common and inexpensive, they just buy a new one for $80, $85 and throw the old ones away. They don't bother fixing them no more. I know he had to have some parts flown in for the rest of this brake, so while it looks pretty standard, I'm thinking it probably has a special offset or something to it. I can hear a little ring in there, but it's not terrible. When they really get to ringing, you got to do something, because your cut, it'll get to vibrating to where it'll make 15,000 steep gouges as it's vibrating. Yeah, it's not just for the fact of making it nicer in the shop. It's important to doing the job, damping that vibration out. Once in a while you can get something like this where you can get the vibration will happen at a high enough frequency to where it just makes a really pretty little vibration surface, you know. It's because you get a real high frequency and then it's only moving like 1/1000ths. And it makes like little fish scales on there. That's usually on harder material. You see that sometimes. Which is sometimes a trick to try. If you've done everything and your vibration just doesn't go away, once in a while, it's not the most common. Usually to fix it is slower speed and damping, but once in a while, high speed will help you by going to a high enough frequency in it so that it just ends up being fish scales instead of big deep gouges. Yeah, I'd say one more will do her. I was just trying to decide if I wanted to go with a little lighter cut or not, but I don't think so. And I noticed I hand wheeled it out even though we've got nice rapid on this machine, which Bert knows about, but I didn't want to use the rapid coming across that and having it jerk a little bit. Just wanted it smoother. Not that the rapid definitely jerks, it's just any possible jerk I didn't want to have. That's an air cut. That's when you start a little early and doesn't quite go into the feed mode, all the way into cutting. That's air cut. Sometimes machinists will do that when they're near lunch, part's actually finished, and they're just wanting to finish out the shift without starting on the next part. They'll back their tool up and do an air cut. Then comes the other question. if you you bore out a brake drum, your shoe is got a curve that it's to that fits a standard size brake drum. So when you bore it out bigger, in the old days they used to have what they would call a shoe arc grinder. And it would take your brake shoes and take all the nice asbestos and a big grinding wheel and throw all the asbestos in the air as it made the curve closer to what fit the drum. And of course, I didn't like that myself. At that time, we weren't worried about asbestos too much. We knew you shouldn't breathe a lot of it, but a little bit, no big deal. And hey, somebody else is going to grind them anyway. I'm just putting them on. but what bothered me was that you're grinding some of your new shoes away to make it fit. Well, there's another thing, and the one thing that they do now, and you can even do it with a hammer, is they peen the back of it, because you've got your shoe with a curve, and then you've got a support rib that goes inside. You take a back up, and you take a ball peen hammer or an air chisel, and you just hit those in a few places, and you can stretch it out and just manually do that a little bit until it fits the drum good. Then you're not wearing material, you're not breathing. Even the asbestos replacements aren't really good for you. So you're not breathing any of that. And that works pretty good. That's what most people do today and what really should be done. They either do that or they just ignore it and let you only get half brake life out of your shoes. Which, if you only turn it 10/1000ths of an inch, it don't matter anyway. I mean, if you're just doing a very minor turn. But if you take a fair amount out on a 9 or 10 inch drum from some old car, it makes quite a difference. You can really see the difference whether it fits or not. I originally thought we might have to want to do these on the big lathe, and if we had the hub, that might have been what we did, because the big lathe would grab the hub possibly easier, the way the chuck is. But the big thing was this one here, the T-slots for those clamps lined up nicely, and on the big lathe it wasn't gonna. T-slots are all out of the bigger diameter, and this, all in all, it works good on this lathe. Big one would have been just clunkier and slower. Wouldn't have helped any. Couple little color marks, but it's not worth taking more of the drum off for that. Well, it's kind of a hard spot, actually. This thing was hot. I still don't think we should take it down more for that, though. So anyway, had to get them parallel because this surface here had 15/1000ths divots in it. So I called them up, and one of the other options would be we could pre-mount it on the hub, but it turns out this is a planetary, so this is a pretty special drum. Most of the planetaries are not common as far as the brakes go. Anyway, so I'm facing this surface here that we will put against the chuck over there to bore out the inside. I'm just using a 3-jaw because that was easy, and I chucked up on the inside, squared it as best I could with the nicest part of this surface. But now we need to face the inside to make it parallel, and you can see how we sneak in here with the boring bar. We're going to turn the machine backwards, and I've already got set on here where I'm at 5.5. That actually ends up at 0 when I go into the point that I want to stop. So I can just reach in, pick up a little cut, start facing it, and then I will have to, again, work with my trusty Blue Point. I almost said Snap-on. It's their cheaper one, mirror light, which the light is not nearly as bright as I was hoping it was. This is the first time I've really used it. I've had that for about 10 years. Austin wasn't impressed with it, and I can see why. And over the dale, and then we could take camera, or we could have a micro drone in there. That would be really cool if we had a micro drone. It could just hover up in there with a little light and camera both.
Put the GoPro on the end of a really long stick.
That's a long, I'm gonna go wobble. I think we're better off sneaking through here.